Let us continue this 1997 AP Calc BC multiple choice. We left off on number 17. So 17 says, let f be the function given by f of x is ln of 3 minus x. The third degree Taylor polynomial for f about x is 2 is what? Okay, so I don't remember the Taylor series for ln, so we can just do it the long way, okay? Because third degree Taylor polynomial, not too bad. We just take 3 derivatives, okay? So should I do it here? Let me just try to fit it in here so I can do it live, okay? So f, let's write it once again, is ln of 3 minus x. So f prime would be what? 1 over 3 minus x times negative 1. We need a chain rule. Okay? F double prime would be, this is the same thing as 3 minus x to the negative 1 power. So maybe let me even write that. Okay, so we can do the power rule and then the chain rule. So negative 1 we bring out to the front. There's already a negative 1 here, so it'll become positive. It'll be 3 minus x to the negative 2 times another negative 1 from the chain rule. Okay, now f triple prime, we could stop here because this is the third degree Taylor polynomial. The third derivative corresponds to the x cubed term. Okay, so this becomes what? Power rule again. So negative 2 times negative 1 would be just positive 2. 3 minus x to the negative 3 power times another negative 1 from the chain rule, okay? So what is f of, the center is at 2, so f of 2, okay? That's just ln 1, which is 0. F prime of 2 is, we plug in 2 here, that would be negative 1, okay? Total negative 1, because 3 minus 2 is 1. 1 to negative 1 is just 1 times negative 1, okay? F double prime 2 is, plug in 2 here, that's 1 to negative 2, which again is just 1, so negative 1. Now f triple prime of 2 is, plug in 2 here, that's 1 to negative 3, which is 1, and then we have minus 1 times 2, that is negative 2. So we can write the polynomial term by term. First term is 0, okay? So second term is what? Well, okay, let's maybe remind ourselves what the general formula is. It's n goes from 0, in this case, to 3, because it's the third degree Taylor polynomial. It's the nth derivative at 2, the center is 2, x minus 2 to the n over n factorial. So the nth derivative of 2, when n is 0, that's this guy, 0 times whatever, it's just 0. So the second term would be minus 1 times x minus 2 to the n over 1 factorial, which is just 1. The next term would be minus 1 times, because this is minus 1 again, what did I write n there? This should be to the first power, okay? X minus 2 squared over 2 factorial, okay? And now the third term would be minus 2 times x minus 2 cubed over 3 factorial. So it's asking about, oh, it's just asking what the Taylor polynomial is. So let's see which one it is. It looks like this one, B. Let me confirm with the key. Yes, okay, because 3 factorial is 3 times 2 times 1, or 3 times 1. The 2 and that 2 down here would cancel, so we're left with 3. Okay, that's how we do this one. For what values of t does the curve given by the parametric equations t cubed minus t squared minus 1, that's equal to x, and y is t to the fourth plus 2t squared minus 8t have vertical tangents, okay? That's when dy dx is equal to infinity. Okay, so dy dx, remember it's just dy dt over dx dt. dy dt is 4t cubed plus 4t minus 8. The bottom is 3t squared minus 2t. Okay, so we want this to be infinite. Okay, so that means the denominator has to be 0. When we divide by 0, it makes it infinite. So 3t squared minus 2t is equal to 0. We can factor t, 3t minus 2 is equal to 0. So t could be 0 or 2/3. Okay, 18 is C. 19, graph of y is f of x is shown above. If a1 and a2 are positive numbers that represent the areas of the shaded region, then in terms of a1 and a2, what's the integral from minus 4 to 4, f of x dx, minus 2 integral negative 1 to 4, f of x dx, okay? So the integral from minus 4 to 4, that's this area minus this area. So a1 minus a2, why is a2 negative? Well, because it's underneath the x-axis, so we subtract it, okay? That's integral from minus 4 to 4, so that's this guy. Minus 2 times integral from minus 1 to 4, negative 1 to 4. That is a2, but a negative sign, remember, again. Okay, because we're integrating, and this is below the x-axis. So this becomes a1 minus a2 plus 2a2, which is just a1 plus a2. Let me double check that. That is correct. Yes. Okay. We have 5 more problems, I believe. Let's continue. What are all values of x for which the series converges? This should signal a ratio test if we do it the long way. I don't see a shortcut way, so I would just do the ratio test. Okay, so that is limit n goes to infinity of a sub n plus 1 over a sub n, if you remember. So that's x minus 2 to the n plus 1 over n plus 1, 3 to the n plus 1, times the reciprocal of this guy, so that's n times 3 to the n over x minus 2 to the n. So we can simplify, okay, this to the n plus 1 divided by this to the n, that's just x minus 2 to the first power on top, okay? 3 to the n divided by 3 to n plus 1, that's just 3 on the bottom, okay? And then we still have the n over n plus 1, that we can't simplify. Okay, this doesn't depend on n, so we can treat it like a constant, move it outside. So it's the limit as n goes to infinity of this guy, that's equal to 1. So we are left with absolute value x minus 2 divided by 3, okay? And we want this by the ratio for the ratio test to converge, we want it to be less than 1, okay? So x minus 2 in absolute value is less than 3, or x minus 2 is between 3 and negative 3, so x is between 5 and negative 1. We have to check our endpoints though, okay? But we can eliminate 2 of them already. We have to check our endpoints to see if they converge. So what happens when x is negative 1? Let me do it up here. We plug in x as negative 1, we get minus 3 to the n over n times 3 to the n, which we can rewrite as negative 1 to the n, 3 to the n over n times 3 to n, and these would cancel. This, we know, converges. This is the alternating harmonic series. How about when x is equal to 5? Let me do it over here. Is it on camera? It is, okay. When x is 5, we plug it in here. It'll just be summation of, what, 3 to the n over n times 3 to the n. We can simplify to just 1 over n. We know this diverges, okay? The harmonic series, p series with p equals 1. So our interval does not include 5, but includes negative 1. So it should look something like that. And that looks like E. Okay, so that's how we do this. Which the following is equal to the area of the region inside the polar curve. R is 2 cosine theta, and outside the polar curve, r is cosine theta. Okay, this I'll show you what I did. Okay, so this you should recognize. If you are comfortable with polar curves and worked with them enough, you should know that this is just a circle. And this is just the same thing, but stretched by 2. It'll be radius of 2. Okay, so this inner one would be r cosine theta. And this outer one would be r is cosine theta is the inner one. R is 2, cosine theta is the outer one. Okay, so we're interested in the area inside the bigger one and outside the smaller one. Okay, so by symmetry, this is not a good sketch, but since they're circles, I just can't draw a circle. Okay, we can see that this top part is symmetric to the bottom part. Okay, so once again, it's not a great sketch, but if you draw it out well, you'll know that just by symmetry of these polar curves also, the top would be equal to the bottom. So we could just worry about the top and multiply by 2. Okay, so how do we get the area here? Well, we can get the area from the bigger circle first. So that'll be everything including in here. And then we subtract it from the area of the inner polar curve. Okay, so with the black pen, the area of the outer one would be the penciled plus the black pen. The area of the inner circle would just be the black pen. So we can just subtract it out. Okay, so how do we get area? Remember the formula is area of the sector. Like that, okay? So again, I said we can just worry about the upper half and multiply it by 2. So that's where this 2 comes from. Half integral from, well, you can kind of eyeball that when theta is 0, it's over here at the maximum. And when theta is pi over 2, it'll be over here. Okay, same thing for this circle. Okay, so we can say it's from 0 to pi over 2 of the outer, which is this guy, so this guy squared, minus the inner, which is this guy, so this guy squared, okay? And we can simplify, this would just be 4 cosine squared. This is the same thing, cosine squared. So it's 3 integral from 0 to pi over 2 cosine squared, okay? So that looks like A. Let me double check that's correct. Yes. Okay. Graph of f is shown in the figure above. If g of x is integral from a to x f of t dt, for what value of x does g have a max? We're interested when g has a max, so we probably want to take the derivative of g. So g prime, what is g prime? That's just f of x, fundamental linear calculus. Okay, so we want it to have a max, so we want f to, if there's a relative max, f would go from positive to negative. So that occurs at point C. Okay, that's how we do that one. In the triangle above, if theta increases at a constant rate of 3 radians per minute, so immediately I want to write d theta dt is 3. At what rate is x increasing in units per time? So we want what dx dt is when x is equal to 3. Okay? So we can use the trig relation that what sine theta is x over 5. Okay? Now we just differentiate with respect to time. So it'll be cosine theta d theta dt is a fifth dx dt. Okay? So we have d theta dt. We want to know what dx dt is. How do we get cosine theta? That's missing from this equation. Well, if x is 3, that's why they gave it to us. So this is 3. Okay? What's the side of the triangle? it's a 3, 4, 5 triangle. If you don't know the special triangle, you could just use Pythagorean theorem. You'll get that it's 4, okay? So cosine of theta is just 4 over 5. So 4/5 times 3 is equal to 1/5 dx dt. So we get that dx dt is, well, this 1/5 and this 1/5 would cancel. Dx dt is 12. Let me double check that's correct. Yes, good. Taylor's series for sine x about x is 0 is this guy. Okay, you should recognize this. If f is a function such that f prime is sine of x squared, then the coefficient of x to the 7th in the Taylor series for f about x is 0 is what? Okay, so I don't have enough safe space here. But I did do this beforehand. I kind of want to do this live though. So let me see. Okay. Let me just do it down here. Okay. We know that sine x is equal to this. So let me write it again. Let me just write these 3 terms even. Okay, so sine of x squared, wherever there's x, we plug in an x squared. So it'll be x squared minus x squared cubed, that's x to the 6th over 3 factorial. X squared to the 5th, that's x to the 10th over 5 factorial, so on and so forth. This is f prime. Okay, so f, we could just integrate term by term. So it'll be x cubed over 3 minus x to the 7th over 7 times 3 factorial plus x to the 11th over 11 times 5 factorial, so on and so forth. Okay, so we can integrate and differentiate power series if you remember. So that's what we did, we just integrated it. So the coefficient in front of the x to the 7th term, so we have that, it's over here. It will be what? Minus 1 over 7 times 3 factorial is 6, so that's minus 1 over 42. Okay, and then the last problem in this no calculus section, closed interval a to b is partitioned into n equal subintervals, each of with delta x, by the numbers x0, x1, ... xn, where a is equal to x0, which is less than or equal to x1, blah, 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 blah. Okay, this should sound familiar. What is the limit as n goes to infinity? Summation as I goes to 1 to n, square root of x sub I delta x. This should also look familiar. This is just the Riemann sum. So we should be getting a definite integral in the end. Okay, so let's find what that definite integral is, and then let's see what all these choices are about, okay? Well, we know that, remember the inside of the summation is f of x sub I delta x. X sub I are the sample points, so it looks like f is square root x, okay? So this is just the integral from a to b of square root x dx. Okay, so this is just, we can evaluate this. That's what? 2/3 x to the 3/2. Evaluate from a to b. So that's 2/3 times b to the 3/2 minus a to the 3/2. So that looks like a. Okay, so this is a Riemann sum one. All right, that's it for this portion of the exam. Hope it was helpful. Please like this video if it was. And as always, also please subscribe to show your support and to also get notified for upcoming videos if you're interested.